let's finish off with the plants, and then we will go into other syndromes of great importance. What I've included here is for the guys in the Western Cape. Chinkerenchi. Okay, now think back to your third year notes. What's the botanical name? Ornithogonum thyrosoides, the star of Bethlehem. Indigenous plant, most beautiful, it's cultivated all over the world. Highly toxic plant, and it's throughout the Western Cape. So think back, what does this, the chinks cause? We get about 5 types in South Africa. This is the one in the Western Cape. Severe diarrhea. I haven't seen diarrhea with anything else as severe as that, as with chinkerenchies. Severe diarrhea, and if you can remember, followed by blindness about 10 days after the diarrhea has started, which is a very, very interesting clinical sign. We have dosed this at the OVI, at the Institute, and we could stop the diarrhea with activated charcoal, but that didn't stop the blindness from developing. This plant looks very beautiful and maybe innocuous. In my mind, per weight, is the most toxic plant in South Africa. It's even more toxic than gifblaar or tulp. It's like 0.1 grams per kilogram. So an animal will need to take in a few flowerets of that and it's gone. And what's interesting about the diarrhea in this, it's not irritation, it's from neurogenic origin. You get a hyperperistalsis and they just show diarrhea for 10, 14 days and they emaciate. They become thinner and thinner and thinner. Eventually they become blind. So if they are blind animals, we always ask, have you got chinks on your farm? Next second best DD is obviously lead poisoning. Then also, just for the guys in the Western Cape, annual ryegrass toxicity, Lolium perennae. I lost my slides here. Ryegrass staggers, you get annual ryegrass and perennial ryegrass. The perennial ryegrass, it's an endophyte again, and these animals show staggers and they recover. The mortality with annual ryegrass is usually very high. And remember, that's the little worm that climbs up to the seed heads and carries the bacterium that causes a poisoning in these animals. Annual ryegrass toxicity. And the farmers usually know how to manage this because the toxicity is caused by the seed heads in the plants, and they would graze the ryegrass to such an extent that they never develop seed heads. So just by a farming practice, you can sometimes prevent, or often prevent, many syndromes or poisonings. Okay, now a subject that I really like, and today I would like you as a take-home message, how to handle fungal poisonings. Because, you know, if you are sick and you go to the doctor, usually if they don't know what's wrong with you, they tell you you've got a virus. Well, obviously nowadays you can't dispute that with COVID going around. But before COVID, if they didn't know what was going wrong with you, they said you've got a virus. Either Epstein virus, or there was a lazy house syndrome, lazy housewife virus, and all sorts of things, yuppie virus, you know. So if somebody makes a diagnosis like that, usually they don't know what's going on. And it's the same if vets usually don't know what's going on. We tend to say it's a swam. Jou kuilvoer is bietjie vol mif. Okay, that's a very vague diagnosis. Okay, so I would like to explain to you how we should approach fungal poisonings, suspected fungal poisoning, and mycotoxicosis. Because these things are specific syndromes. They're not something vague. They're not a diagnosis that you pull out of your back pocket if you ran out of ideas. And I spoke to a vet yesterday, by the way, who was also in the dairy industry in the Eastern Cape about something totally different. So I said, what are you talking about? I hope you are going to talk about mycotoxicosis because they diagnose it very often. But I think it's often being wrongly diagnosed for some reason. Okay, let's look at the major syndromes in dairy animal. We get these ergots, which we'll discuss later. They can grow in any small grains or grasses, can be infected with ergots. And I've got nice pictures that I'll show you. We get aflatoxin produced by the Aspergillus species, Aspergillus flavus and parasiticus. We get deoxynivalenol, zearalenone, T2 toxin, and fumonisin produced by the Fusarium species. So we've got Aspergillus, here we've got Fusarium. Different Fusarium species produce those 4 toxins. Then we get Bacillium species of fungi, and they can produce ochratoxin, PR toxin, mycophenolic acid, and rocafertine C, and that's produced by Penicillium species. And then we get the tremogenic toxins produced by Aspergillus clavatus. Very, very interesting syndrome. So to start off with, we get fungal contamination on everything that we feed. If you send in a sample for mycology, that means not for toxins. That's to cultivate the fungus or fungi growing on any substance that you send in. You will forever get an analysis back because fungi, they are everywhere. So we must distinguish between fungal growth and toxin production. That's one thing you must remember. So under certain circumstances, fungi, that's present all over the place, even where you sit now there and where I'm sitting here, there's fungi and spores in the air. Under certain ideal conditions, fungi will produce toxins. Some toxins are good, not toxins, some metabolites, let's put it that way, are good. If you take the ionophores, selinomycin, rumensin, monensin, they're all metabolites from fungi, and that's good stuff. We use it in feedlots, we use it in the dairy industry, the ionophores. Penicillin is produced by a fungus. Many proteins are produced by fungi, and sometimes we look at rations, and I like it that at least we've got one person here, Professor Lawrence, who is a nutritionist, and we sometimes look at hay or a concentrate and it's moldy, and we say, yeah, you know, it decreases the nutritional value. Let me tell you, and I'll give you an example very shortly. It sometimes increases the nutritional value. So I hope today there's a few myths about fungi that I hope we can dismiss forever. They're not always bad. Sometimes they're very good stuff. And it's your work to distinguish between those two. So just to summarize here again, we get Aspergillus fungi. We get lots of fungi. Here's the most important groups. The Aspergillus ones, the Fusariums, the Bacilliums, and this specific one I would like to discuss separately. They all produce different toxins under different conditions. As a general rule, which is actually a very nice rule for us working with dairy and in feedlots, feeding animals, ruminants to mycosis and fungal poisonings than monogastric animals. Much more resistant. Rumen is absolutely amazing to detoxify mycotoxins. And therefore, I don't advocate the use of mycotoxin. I think it's my personal perspective and opinion. You can differ from me. If you want to use the mycotoxin binders, use it in poultry and in pigs. I think it's an absolute waste to use it in a ruminant because the rumen detoxifies most mycotoxicosis. But if there's excess mycotoxins, if the dose is too high, it will have an effect. Okay.
Okay, Dr. Neil, can we break for a second? For 5 minutes?
Okay, let's make it 5 minutes, please.
Okay. And then we will start again just after 9 o'clock, so 2 minutes not past 9. We will continue with the presentation. Thank you.
Thank you.
Awesome. Okay, Dr. Neil, welcome back. If you're ready, we can start again.
Okay, I hope, Elena, I hope you all hear that nobody has run away in the break.
I would like to ask you a question, but
Yes.
it's not so ever one of these high-level questions. If you've got
Okay.
a garden full of chinkering cheese,
Yes.
will it pose any threat to your domestic animals?
It's a good question. It is highly toxic, and our domestic animals tend to eat lots of garden plants, and we pick up problems with that. I've never had or encountered problems with chinks in a garden. Should you, however, and we've seen that where people clean out garden plants of whatever source and they throw it over the fence because they think the animals will eat it, then we'll get serious problems. We had it there next to Onderspurt where somebody cleaned out their rockery with all these succulents, the pluckies, and they killed I don't know how many animals because of the cardiac glycoside in those pluckies. So that can happen. So yeah, it's a hard one. But when you invite me again, I'll talk about toxic garden plants. But let's go on with the dairy animals. All right, the mycotoxins. This is I got this from a publication. I will tell you exactly with which mycotoxins I've got personal experience with and which I got from a publication. Now you can see how vague these things are. And this gives me huge problems. The first one is not very difficult. The effect of mycotoxins, reduce feed intake and feed refusal. Just remember, feed refusal, one of the most prominent signs causing feed refusal is the ionophores. It's not anorexia, it's feed refusal. But anyway, fungal infected feed can cause reduced intake and feed refusal. And that's measurable. A reduced nutrient absorption and impaired metabolism. How do you measure that? I'm telling you, that's why when these things become vague, I also become vague. The third one is even more vague, altered endocrine and exocrine systems. How are you going to diagnose that? Extremely difficult. Suppressed immune function, we all know that, especially with aflatoxin. And the only thing that you see is obviously all sorts of diseases jumping up especially in poultry and in pigs, because you've got a suppressed immune system. And then also altered microbial function. This is most probably the most important ones. So the point I want to make with this slide is there are very difficult syndromes caused by fungi or mycotoxicosis to prove, and then there are easy ones to diagnose, and we will discuss them all. But in the end, I would like you to know how to approach a case where you suspect fungal infestation or mycotoxicosis. And Helena, this thing is not going down anymore. What must I do? Oh, there it is now. The diagnosis of mycotoxicosis is not different from what I use as the 5 pillars of a diagnosis, of any diagnosis. And we'll come back to them. The history is extremely important. They teach you that, and we never do that. When somebody sends samples for an analysis to a lab, they just send in and there's very scant history or nothing at all. It's extremely important. Clinical science, a full description of the clinical science. Pathology, extremely important. Complete pathology. Chemical analysis, if needs be, or fungal analysis. That's your 4th pillar of making diagnosis. And then your 5th one, if needs be, we sometimes needs to induce the syndrome in a laboratory animal. By meaning laboratory animal, even the same breed of animal. What I often do, because nowadays, when I was at the OVI, it was the period before ethical committees and protocols and that sort of thing. If you wanted to test a suspected toxic ration, it would take you a year to get permission. And that's why at most of these facilities, nothing is happening anymore. At that stage, we could test things immediately. What I often do nowadays, if I suspect a feed or even a medication, a farmer would call me out and he would say, this vaccine has killed 10 of my animals. And I would phone the company and they sold 100,000 doses of that specific batch of vaccine. No one is complaining in South Africa except this farmer. So I would do a trial on his farm using some of his own animals and inject it myself with a clean syringe and needle, and to show him that it wasn't caused by the vaccine. That's what I mean by laboratory animal testing. The other day, a vet from the Highveld phoned me. He said he's got a fungal problem. He thinks, I said, all right, now what you do is take some animals that were not exposed to this fungus or the feed and feed them for 2 weeks and let's see what happens. Do your own little trial. That's what I mean by that, because sending stuff into a university or to the OVI or whatever, you're not going to get a result back because they're not able to do it. But these are the 5 pillars of making a proper diagnosis, and we'll get to them one by one. And it's the same with fungal analysis. Remember, initially said it's not a vague thing. If I don't know what the hell is going on here, I say it's a fungal poisoning. Your food is bietjie gemif oom. That's nonsense. Okay. Fungal analysis. I'm not talking about toxin analysis now. Let's get this clear. Is done by the Plant Protection Research Unit Institute. It's an ARC, an Agricultural Research Council Institute. ARC. There are 11 institutes of this, of the ARC. This one is at Roodeplaat Dam. And I've even included the telephone number for you of this institute. Because let me tell you, in this year, most probably how many fungal or suspected fungal poisoning diagnoses were made, I can promise you, not one of those samples was sent to this Plant Protection Research Institute, because most of our vets don't even know about the existence of this institute. So this is the starting point. If you've got moldy feed, you start here. You see what fungi are present. So these people don't test for toxins. They test for fungi. They grow them. And it can take you a week to a month before you get analysis. But then you know what fungi are present in that feed. If you know the fungus, then you can go to the literature. Before you even look for toxins, you can go to the literature and say, yeah, all right, yes, Aspergillus flavus in it. We know from literature it produces aflatoxin. Our here is Fusarium, whatever, in here, and we know it produces that toxin. But then you know what fungi are present. So, in my opinion, you can't make a fungal diagnosis without sending a sample to the Plant Protection Research Institute at Roodeplaat, where they grow the fungi and not looking for toxins. You need to do that, and this is never done. And I'll give you a very good example where I do it and where I did it in the past. Write down the telephone number, you guys that's going to send you samples there, get it analyzed. Be scientific. Don't use a fungal excuse if you can't make a diagnosis. The toxin analysis is something totally different. The mere presence of a fungus in feed doesn't say that the toxin was produced. Remember that. They need certain conditions, ideal conditions, to produce the toxin. The toxins can be analyzed, or some of them, by the Toxicology division at the OVI, the Institute. There are certain commercially available test kits that can test for like 5 mycotoxins and quantify them, like aflatoxin, ochratoxin, T2, deoxynivalenol, and maybe another one. That's a standard kit that these labs buy. Many other of those ones I've listed and I've shown you cannot be done in South Africa. They must be sent overseas, and we do that. But let me tell you, it's not like we are third world and that we can't analyze things. The international people also have huge problems in analyzing mycotoxins. It's a highly scientific field with very sophisticated instrumentation in a laboratory. to analyze for these toxins and to quantify them. That's very important and extremely difficult, which make mycotoxicosis and the diagnosis and confirmation of a diagnosis in certain instances very, very difficult. But I want to repeat myself. Do fungal analysis. Send them to the Plant Protection Research Institute. Then test for toxins that are easy to test for. And then we can come to some sort of occlusion. Also remember something else. Although I think that fungal analysis are often overemphasized, I will be the first one to admit there are many fungi that we don't know anything about. What they cause, what toxins they produce. I'll give you an example. During that period when I was at OP, we had this most fantastic team in South Africa consisting of scientists at the CSIR, us at the OVI, a whole team working on fungal analysis. So I know Dr. van Dijk, who's the manager of the MPO, wants to entice some of your vets to become dairy vets. I would like to entice you to become a toxicologist and work on mycotoxins. They're the most interesting field of research, and we know very little about these things. But this research has come to a grinding halt in South Africa about mycotoxins in food-producing animals. So yeah, the fungus is analysis or the fungal analysis by plant protection, and then other labs will do the mycotoxin, the toxins that are formed.